I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEP going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
Everybody look like you're really, really interested in the talk and excited. Okay, that's out of the way. So hi everyone, my name is Ed Arenberg. I've been a developer for probably more time than some of you have been alive, it feels like. But we saw the very early days of the internet. I think I started my company in '93, when basically you hand-coded the web. There were no tables. You could do blinky things, and you could change font colors and things about like that. But amazing how much that grew. And we kind of rode that wave through the whole boom and bust cycle. And then in the early 2000s, it was like doldrums. Before Web 2.0 came out, and basically there wasn't much activity going on. So we started looking around for something else to do. What else is out there on the horizon? And we started playing around with mobile. And back then, we had the Palm Pilot, we had BlackBerry, and anyone ever developed for BlackBerry, my condolences. It was a bear. But then the iPhone came out, and obviously, as you all know, that totally changed the world, and we just shifted the focus of our company to building apps. And like a lot of people in those early days, we didn't know what we were doing, really, but we gained enough experience by just building our own stuff that people started coming to us, our power clients on the website, and said, yeah, we need an app now. And of course, that was the mantra back then. Oh, there's going to be an app for that. I need an app. Everybody needs an app. So we started writing these little basic apps for all of our clients. And then as iOS grew up, we kind of grew with it and started developing more sophisticated platforms. And now we're pretty much just do a lot of contract work for clients from little startups all the way up to some Fortune 100 companies, all kinds of different areas. It's one of the nice things about being a contract developer. I don't know if you heard the talk yesterday about it. One of the benefits is you get to put your toes into all kinds of different technologies. And I will admit, I would have never gotten into Unity if we hadn't had some inspiration to try to figure out some ways to create a 3D environment that was going to be cross-platform with some native experience on top of that. And that was kind of the genesis of this back in about 2018 or so. We started diving into it. And in those early days, Unity didn't really want you to do that. But some people had kind of figured out a hack. Well, if you take these pieces of the Unity project that you would normally just build straight into a project, and then you get your workspace and you figure out how to pull this piece out and load that piece in, you could kind of make it work. But you had to do that every single time you made a change. So while it was painful, it did kind of work. So we started building up this concept of, well, let's make this hybrid environment. And back then, we still were basically on Objective-C and UIKit apps and all. And about 2 years ago, we finally started to take the plunge and said, okay, let's start looking more at SwiftUI, and let's see how we can build a more cohesive feel for that. And so that is kind of the genesis of this work that you're going to see today. Okay, so who here has actually used Unity? Okay, a few people dabbled in it. You know, it's out there. Fortunately, for those who haven't, there is a free version. You can just go get it, use it, play around with it. My one pet peeve of Unity is that they frequently put out minor updates to it. It's kind of like Facebook. We just keep updating little things. They don't really improve that much, but they get a minor update. So if you're working in a group and you have everybody's kind of working on that project, you all have to be in sync on that same version, even though it's a minor update. So normally, you go into Unity and you build your project and you get this amazing experience. Maybe it's a game, maybe it's just architecture stuff, maybe it's some VR experience, whatever it's going to be. And you would export that out of Unity into a Xcode project, and you just go into Xcode and build it. And now you've got your app for Xcode, or you export it for some other platform, and you build it for there. But in 2019, I think Unity saw all these developers kind of hacking their way through, how can I embed this into a native project? And they came out with their own formal way to do it. So literally in Xcode, or sorry, in Unity, there is an export as library checkbox you can do. And so when you make your build, it comes out as a library that you can then embed into a Unity or Xcode project. Downside is that that library is Objective-C++. And so you can imagine that when you start to integrate this into a Swift and SwiftUI environment, you're going to run into a few roadblocks. And hopefully, by the end of this talk, you'll kind of see, OK, we can actually plow our way through some of those challenges. So now SwiftUI, everybody's using SwiftUI, right? Pretty much, almost. But that's that new compositional reactive framework from hotness from Apple. And one of the nice things, it does integrate with the old framework. So if you still are UI kit, you can kind of meld together and slowly kind of put the pieces together. But SwiftUI does abstract a lot of the startup and the initialization process that we might have had access to if we had the old Objective-C UI kit applications. So integrating Unity, again, does present a few challenges. So why would we ever even want to do this? Well, Unity's a great 3D experience. You can build all kinds of experiences with it, but the user interface, if you've ever used a Unity app, it's not native. It feels a little clunky. The buttons don't respond right. All those issues you might have if you wanted to bring it into the iOS fold. And SwiftUI, you get great interfaces for it. You can build great experiences, animations, and buttons, and styles, and colors, and all that stuff. So let's figure out a way we can put both of those together. Great user interfaces and great user 3D experiences. So that's one reason, but perhaps I'm going to entice you with one more thing that maybe gives you a thought that maybe this is something I want to look at, and that is the future. And if you saw Mac Rumors on Monday or Sunday, I think they had a little article that Apple's now applied for trademarks on a whole bunch of reality this and reality that. So I think it's coming pretty soon. Maybe early next year we'll see the actual headset, and who knows when the glasses will come out. But that's going to be your first foray as an Apple product into building something for 3D. OK, so what we're going to build today is going to be a real simple demo app. And I'm not going to do all the building for you, no live coding, thank God. But the app itself is just going to start off with a SwiftUI view. It's going to have a little button on there that's going to launch and kick off our process for initializing and establishing Unity and getting all the communication stuff set up so that when we build our two layers that we actually want to show, there's a way for those two to communicate together. To do that, though, it's a bit of a puzzle. There are a lot of little things you kind of have to work through to make all that happen. So first, you got to build a Unity app. And thank God, we're not going to build any Unity today. But you've got to make your Unity experience. And then it's fairly easy. You can export that as a library and then integrate a workspace so that you can have your native code along with the Unity project itself. We'll create a real simple launch screen. So that's going to be our startup point where we'll be in SwiftUI. And that will kick us into the Objective-C land where we'll start to do the integration with Unity. That will create an app delegate object. It's just what I call it, but you can call it anything you want. That actually does the heavy lifting for initializing Unity and establishing the communication paths we need to talk from native to Unity side. So we're going to go out and find some way to get our launch arguments so that Unity itself can then be initialized. We can then write SwiftUI to our heart's content, whatever kind of UI experience we want, no limitations. That's going to be the layer that we will see on top of our 3D or our Unity views. And then we're going to add some components to make that communication possible so that actions that happen on one layer can interact with the other layer. The first step, build your Unity experience. Now, if you've never seen Unity, it looks pretty dense. There's all kinds of things, the menus and stuff. And I'm sure the first time people look at Xcode, you kind of have that same glazed over look. It says, what is all this stuff? Fortunately, there's tons of libraries, plugins, sample code, tutorials, support groups, online courses that kind of walk you into it and get you started. There's even whole basic apps, environments that you can just get, and tons of plugins you can purchase, or there's a bunch of free ones. So they can get you started. Unity published this example. So this link here is their GitHub project for how do you take a Unity framework or project and export it as a library to use in another project. And they have some documentation on what the process, what the commands are, or how you kind of set stuff for iOS. And it does walk you through a lot of the steps, but again, you have an Objective-C UI kit app experience out of this. And hopefully, nobody is building greenfield projects with that environment anymore. Few things to note. Unity itself does have a bit of an overhead. A bare bones, nothing Unity project is going to add about 100 megabytes to your Xcode project. And as soon as you start adding components and textures and elements and stuff, and it's going to grow, definitely grow from there. And then the other piece that we'll see is how to actually put those together. And we'll kind of look at that in a second. All right. So now, in our puzzle, we've got the first two pieces done. Unity project, we've exported our library. Let's move on to Xcode. So in that GitHub document and in their documentation, they do explain the steps. If you want to build, create your own workspace, what do you do? And the sample project has one you can actually start with. So if you want to start ripping things out of there and putting your own stuff in there, that's a good place to start. And these are just sort of the high level, these are the basic steps that'll happen that they walk through for your workspace that you want to create. The last step that they'll note is running some code in main to initialize the Unity framework. And this is where our SwiftUI challenges begin. So we'll come back to those, but for now, we at least have our Xcode workspace set up. 3 down. Two of the biggest problems we'll have with the SwiftUI are that we have no main function. There's no place that the Xcode doesn't build that in our project, so we need to get some arguments out of some environment and runtime in order to start Unity. Unfortunately, the NS process info class has facilities for looking into the runtime and getting back those properties that were sent into the app when it launched. We'll take a look at that later. One last one. Go back. No hosting controllers. So in Objective-C, you don't have access to this UI hosting controller, and that's the code in Swift that lets you, or in a UI kit, basically in Swift, that allows you to embed a Swift UI view inside of a UI kit view controller. And since we're foundation and stuff and everything came out of Unity is all UI kit based, we need a way to establish that our overlay views are going to be able to be viewable from Objective-C. So we're going to have to write some sort of code to vend that out back to Objective-C. All right, so workspace setup. Let's take a look at a little bit of code. And this is some basic high-level structure. We're going to just have a little body here that's going to have a navigation view with a navigation link that's going to take us into our Unity experience. This is just a basic view that then launches or shows this UVC class that I defined. It's just a struct, and it's a UI view controller representable. So this will wrap a view controller, a UI view controller, inside of SwiftUI, so that we can display that after our launch. All right, so a very simple entry page. You can make an app that's much more extensive and embed the Unity experience anywhere within your app, but at some point you're going to need to move into that UI kit, SwiftUI, or UI kit Objective-C world. But for now, we have a real basic launch component. Next up, we're going to dig into actually building that UI view controller. And so here we've got our content view. There's our Unity view we're going to go to. Our UVC is a UI view controller representable. And these are kind of the high-level things. We're going to walk through these pieces on the coming slides. But I just called the view controller my view controller. That's nothing special. You can call it whatever you want. And then it's going to create this app delegate object. And this will do some of the heavy lifting for all of the initializing of Unity, loading the Unity framework, getting the view itself, and it will render full screen. Talk about that. And get the Unity framework view. So when you do launch Unity, this is a caveat, it will be full screen. You don't have a way to embed it in a smaller piece inside of another view, either in UIKit or SwiftUI. So you have to basically live with that. So all of your native experience is going to have to layer on top of that. We're going to get our view because we're going to need it later for integration, and then we're going to add our UI for SwiftUI in a hosting controller. Okay, that UVC struct, it's just a UI view controller representable, and all it's going to do is instantiate that my view controller object and return it to us. So SwiftUI can now embed that into a SwiftUI experience or view. Pretty simple. The my view controller then has to do a few things. Now we're in Objective-C land, in UIKit land, and it's going to do a few things. First, we're going to create our app delegate. We're going to hang on to it because we're going to need it a little bit later. And we're going to tell the the delegate about ourselves. So yeah, we're binding ourselves together, but these things are going to be long-lived. They're never going away as long as the app is running. And then we tell that app delegate to call this function init Unity. And that's something we're going to write. So that's the Objective-C part of the code. It's not, for the view controller, it's not too bad at this point. You know, it's just a little glue logic to put some things together. Okay, almost halfway there. Now it gets a little bit more involved. So the next step is the app delegate. And we have this init Unity method that we're going to write. And its first thing it's going to do is grab the framework from the library that we exported out of Unity. And that will be in our project. That framework is our method, our tool for communicating with the Unity experience so that we can, in native code, get access to the components in there, send messages to it, et cetera. So we're going to need to lock that away in our own property. And then we have to do a bunch of setup. So we need to tell the framework where the content of your app is. So this is the default place that Unity, when it exports your Unity code, so all the 3D experience stuff, this is where it's going to reside. So we just have to tell it that's the bundle you're going to go be looking at. We're going to register this app delegate as a listener for events coming out of Unity. And we're going to register this class for native calls so that if Unity needs to talk to us on the native side, this is the class that will receive those messages. Now we're ready to start Unity. And all we have to do is call the frameworks, run embedded with arguments. Now, what are these? Where are we going to get these from? As I mentioned, we have no main function, so how are we going to figure out how we're going to get these arguments? We'll come back to that in just a second, but at this point, at least we have the structure for our app delegate put together. And let's plug that piece in. Okay, so our next challenge is to get the arguments themselves. Now these, if you've ever written any C code, they are the parameters that get passed into your main function so that you can say this function with this dash this, with this property dash that, with this property and stuff, and it all shows up in these two parameters called argc and argv. Argc is just the count of how many parameters there are, and argv is a handle. It's a pointer to a set of arrays of null-terminated character strings. And so you could have a whole bunch of them all pointing to these strings that were passed in when the app actually launched. We can get the count pretty easily. Just count the number of strings. So NSProcessInfo has a couple methods. object you can create, and then the arguments method to extract out the array of arguments that were passed into the program. But they're all coming back as NS strings. And Unity needs them as character pointer arrays. So what I have here is some really ugly Objective-C code that establishes or allocates some space and then copies them off as UTF-8 strings back into our pointers and has them null terminated. And then at the end, we string copy them all back into our argument set, and we lock that away so as we can then use that to initialize Unity. Hopefully, you can just copy, paste that in, and never have to look at that again. It just works. Okay, we now have the arguments that will launch from our launch state. The next step is to actually run the initialization of Unity, but there's one more piece that we needed access to, and that's that launch ops. These are the ones that normally a UI kit would get when the app delegate gets called with did finish launching with options. It's these launch options that we're looking for. Unfortunately, SwiftUI has a way that you can establish a class that will still receive those old UI kit app lifecycle events. You can add all the lifecycle events you want that were the same as UIKit had. We're only really interested in this one, so this is the only one we really need to implement. And that'll allow us to grab our launch options, lock them away in some global so we can get back access to it when we need them in our app delegate. And with that, once we've run this command, Unity will start. It'll show up, it'll start launching its code, it'll start loading the library, add all your elements into it, and you're good to go with a Unity experience. So if you didn't have anything else to do, you will now at least have a Unity experience inside of a native app. Okay, plug that Unity piece in. Now we want to write an overlay. We'd like to take our real user experience, the stuff that people would be more familiar with, as a SwiftUI layer. We would like to layer that on top of our Unity view. So kind of a summary of where we're at. We started with our Unity view. We created our view controller representable. That was that myViewController class. It initialized all the Unity stuff in the app delegate. And now we want to add a SwiftUI hosting controller to our UIKit experience. So this is the structure that will allow us to write all our SwiftUI views, starting from the root view, and show them inside of a UIKit-based app. We'll need to create a factory method since we're in Objective-C land. We'll write this over in Swift. That will vend out our UI hosting controller that will embed our overlay view. This is what I just happen to call it. And once we've done that, if we're all successful, we will see now a SwiftUI view sitting on top of our Unity experience with a little bit of bridging code between them. All right, so this is the factory method class. So it's basically a static method I can call that will make that SwiftUI view. We'll need to create our overlay view. So whatever you want to put in here in your views, this is where it will go. And you can, again, be as verbose and extensive as you want in creating your SwiftUI experience. This will embed it inside a UI view controller. One thing about UI view controllers is they have an opaque background. So if you stopped here and said, OK, I'm good to go, all you're going to see is your SwiftUI view. And the Unity will just be covered over. You won't see anything. So you got to make sure you tell that view of the view controller to be clear. And not only will that show stuff through, but it'll allow interactions through then to our Unity view underneath our SwiftUI view. OK, so here's a little bit of code in your app delegate to call that factory method, create the view controller. We're going to lock that away because we're going to need it later. And then we're going to basically embed it as a child view controller inside of our myViewController. So myViewController already has the Unity view in it. We're going to add the SwiftUI view as a child on top of that. And we'll make sure the bounds fit, so the frame's sized right. And if you remember, the view controller is the my view controller reference we locked away earlier. And view is the Unity's root view that we also locked away when we got it from the framework in one of those earlier slides. But these are the essential components. Once you've done this, you're done, effectively. You now have our SwiftUI view plugged in on top of that. And if you ran your app at this point, you would indeed see SwiftUI layered on top of it, and then Unity sitting beneath it, and you can interact with the Unity layer, and you can interact with the SwiftUI layer, and everything's going to look great, but there's one more piece, and that is communication. How are we going to make these two layers talk to each other? So there's two ways we need to do the communication. First, say from the Unity side, if there's something that happens in Unity, whether you touch something or an event, a script generates an event, you want to be able to send that message over to the native side. In this case, for example, we make sure that Unity has launched first before we start to present our SwiftUI experience, so we can't interact with the SwiftUI side yet until Unity is ready. So in Unity, this is all C# code. We would establish that there's this external function somewhere out there in native land called Unity Ready. And then we would internally call the start method. Okay, Unity's done loading, let's call start. And then we'll establish that Unity is ready. We'll send that message over to our native side, which again, we mentioned app delegate is our listener. That's the class that is listening for all things coming out of Unity. So we're going to have to implement a little bit of Objective-C code here for when Unity is ready in this method, but then you can call out to Swift. So you don't have to be stuck in Objective-C land at that point. One caveat I'll note that if you are making a cross-platform app, you definitely want to wrap all these calls inside a conditional compilation to make sure you're on the right platform before you call this. You know, we have a platform where it's both iOS and Android, so we have all these wrappers around the calls to call the Android side or call the iOS side appropriately. If you didn't do that and you're on the wrong platform, your app would just crash inexplicably and you wouldn't have no visibility into what actually happened. All right, so now we've got stuff coming from Unity to the native side. If we want to go from native to the Unity side, that framework, the Unity framework we mentioned, that's why we locked it away so that we can send messages to it. And it provides this method called send message to with name. And I don't know where they came up with that method name from, but that's the one you need. And it takes 3 parameters, a script name, a function name, and a string as a message. And again, unfortunately, it's C code on the other side, so we need a UTF-8 string to be able to send across in that message. Now, in Unity, all scripts are attached to objects. So all your code is attached in a script, and the script is attached to an object, and objects can have behaviors, and it gets a little bit confusing because you got all these pieces that are all tied to other different elements. But with this methodology, you can call into any script that you've established in the Unity side, and any function that you've established there, and send it a message, a string message. You can make that message anything you want. So you can encode it in any way you want. This is a real bad code to encode a little bit of JSON and encode it as a UTF-8 string that embeds a key and a value. And so over on the Unity side, we can use some C# code to parse that message and get back a variable and go look at the property that was saved in there. So you can embed that this is probably pretty fragile. You want to make sure that whatever, if you have 2 people writing side on 2 different sides, you want to make sure you got a really good spec. What am I sending in and what am I expecting to see on the other side? Otherwise, debugging this communication path is a real pain. So just a caveat. All right, and those are really all we need. You can make those calls and methods pretty extensive. Whatever you need to communicate between the 2 layers, it's all there. And so now we have finished our last piece of the puzzle. All the elements are there, and if you ran your app now, you would see it, you'd be able to interact with it. So how about a little demo? See it all actually working. So I showed you that this is going to have this little app with a start action, but this is the app experience I'm going to show running. And what we have here is a Unity view in the back It's got some sort of 2.5D-ish map you can interact with and scroll around on. And it's got some Unity controls. So obviously, they're not native controls, but these are Unity elements that you can turn on features and stuff inside the map. We're not going to get into all of that. The key component we want is that we have this SwiftUI layer on top of our Unity experience. And it's got a couple buttons. The main button here is to show an alert. What that'll do when we tap it is it'll send some code out. Eventually, it'll get over to Swift, and that will, or at least our native side, and that will send a message over to Unity. Unity will do whatever processing it's going to do, and then decide to send a message back. And then we're going to show a SwiftUI alert on top of our Unity experience. OK, so this is the demo. Now, I've slowed everything down. If I just ran it, it would actually run pretty fast. So I put some delays in the process, so it will look like it's actually working and doing a whole bunch of real stuff. But first off, we're going to start our Unity. And now you can see Unity launching. So this is the standard Unity launch. And it builds up its views. We're going to tap that button. It's going to send something native. Native is going to go to Unity. And Unity comes back. And hey, out comes our SwiftUI alert. So a pretty simple demo. But from there, you have the foundation of everything you need to build up a more extensive experience. It's really nice that once you have that running, you don't have to go through all those steps again. That whole integration process, establishing all the delegate stuff and all those components, you do that once. You get your stuff running. People can go and build Unity to your heart's content at that point. When they do the export library, it just plugs right back into the Xcode, and you can write your SwiftUI views and test them and interact with them. You know, you'll have to do the integration to test the communication components, but that way you can kind of keep your teams kind of working on whatever elements they need and get that whole experience put together. So that is SwiftUI and Unity. I hope you find it interesting, even if maybe you never use it, or at least maybe not till sometime next year. You might consider it. But I'm happy to take any questions at this point. Thank you. Oh, OK. Well, take a little applause. OK, let's start in front. So it will work with Jetpack Compose, but you probably have to go back into a little bit of Java side and the standard set, similar to what we were doing here. We haven't made the leap to Compose yet on our Android development. We're kind of getting there with the Kotlin and the whole thing, but it's been a little slower migration than the SwiftUI components. So the question was, have we done anything with Jetpack Compose on the Android side of this? And for us, at least, we're taking a more cautious approach to migrating our Android, at least for this project. Yeah?
How do you handle crashes with the games?
Yeah, so the question was, how do we act working with interactions?
Crashes.
Oh, crashes. Yeah, that is always interesting because you don't really get a great pointer. Who caused the error? Where is the problem? So I think the key thing is in that communication layer. That's where you're going to really see that, because you can develop your SwiftUI code, independently, and hopefully you can get the layers. It's that communication path where you're going to really run into trouble. And Unity, you can run that experience completely independently. So the Unity has a great debugger. You can run everything into their simulator, and you can export again into your app, and you can debug a Unity app independently. And again, you can debug your SwiftUI components independently. But that communication layer is where we initially had the problems. And like I said, you better make sure your contract is good between what native is sending and Unity is expecting, because those crashes are indecipherable. And but at least if you kept going to those kind of indecipherable, OK, it's probably the communication. Let's go review what I thought I was sending and what you thought you were receiving. Does that answer the question? OK. Anyone else? Yeah.
For your communication layer, are you basically just limited by what you can convert to JSON and back out to JSON?
So the question was, are we limited in the communication by JSON, basically what we can encode to JSON? And no, we're actually more limited by the fact that it is a string. So you can encode anything you want in there. So if you wanted to use Swift codables and embed that create that as JSON and then pass that into UIKit, or Objective-C and then pass that message across. Yeah, you can do that. That's actually what we're doing. We have codable Swift objects, and then we have the encoding process over and send that over as a string. And then same coming back. You know, when we get a message coming back, it's coming back as a string, and we are parsing that back out appropriately. Yeah.
So the idea is that in Unity, we create our 3D scene, like a racing car. With, it's a racing car in the loop, and then we can use SwiftUI buttons to control that racing car. Okay.
Yeah, so the question was, you know, you can have a 3D Unity experience, and you can then have the SwiftUI component on top, or if you want to, say, have a racing car or something, you want to control that, you want to do SwiftUI buttons, yeah, absolutely, you can do that. We haven't really done a full-on performance test to see what that latency really is. As I said, I slowed this demo down just so you can actually see that things might actually be happening. Our experience is pretty quick, but if you were trying to do a racing game, you know, for that layer, it may be more appropriate for some of the HUD stuff or some of the settings or some of the configuration for your app. That may be more appropriate. But if you want the absolute fastest responsive stuff for the game, you might still want to keep some of those controls in Unity. Okay. Any more questions? Okay, so I want to leave you with a few thoughts. I see I just got rated a 10 back there by the moderator. First off, this is not necessarily limited to Unity. You know, if you're building a SwiftUI experience and you're trying to integrate some other packages that maybe don't behave well or they're limited to Objective-C or CLand, and you want to find ways to kind of link those together, some of these elements and stuff and how you can make the bridging happen still apply. So not just a Unity kind of thing. And I also want to say expand your thought process. I mean, if you're building a experience in an app, what does 3D gain you? You know, or 2.5D, or whatever kind of thing you want to do, and have that animations and all the things that a 3D engine can give you a kind of a really nice experience that Apple, at least in my view of it, seems to have abandoned. I mean, if you're trying to write a scene kit app these days, it's like, why are you doing that? Unity is full on going ahead, and like I said, you're not limited to games. We're doing maps, and we want to use maps as our 3D thing, so we have elements that can pop up and interact on the map, and we draw lines on that map, and we can draw paths, and all these interactive, ephemeral, kind of temporary things, and all show up in our Unity experience, and it's great, and that goes cross-platform, so we can export that as one project, runs on iOS, runs on Android, we don't have to worry about re-implementing it on 2 different platforms. Yeah? I'm sorry, why has Unity not added an export option for Swift? Yeah, it sure would. And maybe they'll watch this talk and go, we never thought of that. Let's go get going. I suspect Unity has bigger fish to fry. If you've been following the news with them, they've been merging with an advertising company, and they're trying to keep their market share afloat and stuff. So it may be a long time wait for that. In the meantime, we do have a way to do it. Yeah?
And then, do you always put all of your Unity stuff into one export, or do you have like a common Unity framework and then another apps or project-specific library? And so can you import both of those, or is it a one and done deal?
So it's a one and done as far as the Unity itself export. Now, I suppose it's possible you could have multiple Unity experiences that you wanted to then export different libraries. I'm not sure how, you might initialize them independently and stuff, but it's possible you could then have multiple Unity experiences within an app. So the question was about initialization on Unity itself.
And we would see that made with Unity with each library.
Right. Each one would export its own library. So the question about library export and can you have multiple libraries and yeah, at least as far as Unity is concerned, I think it's totally independent of what you actually run that inside of. Okay, well, thank you very much. Go download Unity and go to it. Thank you.